This may be the final ourProbes, at least development blog video. So this one I'll just go back to the ESP32, the MicroPython code. I added in some additional probe types, so support for doing pings and webPage time to first byte. I'll go through that. I'll have a look at the code I use for that. Also, I wrap the whole thing in a try-catch block. That's to make it more reliable, so if something does happen, it just reboots itself. And I'll have a look at I optimized one of the routines, so it's where I reused it a lot rather than hard coding it. I've set it up as a reusable routine, and that makes it more reliable as well as cutting down the amount of code. Just to let you know, so the ourProbes videos 1 to 10 really cover the architecture and the MicroPython side of things, whereas ourProbes 20 to 26 is more about the Angular front end. Pretty much got most of them done, so I think what I'll do now is do a more production type video on the actual ourProbes system overall, and wrap that up, and then probably start on a new project after this. Okay, 3 things I'll go through on the Python code that I changed. So this is the code that runs on ESP32. It's MicroPython code. So first thing is the use of a try-catch block. So you see I've wrapped almost all the code for this in a giant try and except, not catch, except block. So if anything fails in between the try and the except, it drops out with this, where it'll print out what the exception is. It'll say it's waiting for 60 seconds, and then it'll go to sleep, and just the normal ending of the code will cause a machine reset. So if anything really bad happens, and kind of the most common thing that's happened but hasn't happened for a while, is to run out of memory. So it's probably a fairly safe thing to do to reset at that point. Also, if the network disconnects, it'll go through this try and accept and reboot. The next thing I did was to support additional probe types. So we see in here, it looks at the probe type. So I've added probe type 2 and 3. So 2 is the the echo probe type. So echo, it just does a simple ping, it doesn't do the bing. So I'll get the round trip latency, but won't try and work out what the bandwidth is. And then finally, if probe type is 3, which is webPage probe type, so we'll go out, try and open our web page as the target. It'll look for a string to be present in that web page, and it'll capture the time to the first byte, so the time it took from when it started going to the web page until it saw that string as the measurement. So it'll capture a time to first byte measurement and a success measurement. In that case, if it fails, it'll print out what the fail code is, which is usually going to be the status code returned from doing the HTTP GET. And then the third thing I did was generalize this uMeasurement, writeMeasurement. So before I had it hard coded in here multiple times, which, as well as being bad coding practices, was using more memory, because at least to get the MicroPython Py file down, I was using up more room. So I didn't have a lot of room on the device, so anything I can do to clear that up helps out. So you see this is called a uMeasurement, writeMeasurement. It takes the probe object, the measurement type, so hard coded is bit per second, round trip latency, and so on, and the particular result that's going to be stored in the value for that measurement. So I'm using that all the way through here. The actual code for that's in the uMeasurement, and you can see here it takes the probe, it builds up this measurement object, which takes the probe ID, the probe name, the current universal time, the value that's being passed and the type that's being passed, and adds that as a measurement. And probably one more thing to look at is I also added one more measurement for when the probe first starts. So you can see it here, uMeasurements, writeMeasurement. In this case I don't pass a probe but just hard code an object that has the fields that are used by writeMeasurement about the probe. So ID I leave blank because there's no probe associated with startup. The name I pass the IP address that was assigned. Startup as the measurement type, and then also the free memory. So this gives me a way of going back and looking through the measurements, usually through doing an extract in the Angular client to look for the startup type, and I can see if things are starting up more often than I'd expect. So normally they should just have 2 startups per day as the JavaScript token expires and they go through a normal restart. Okay, do a little deeper dive on the web page probe type. You see here I'm calling a library called webPage that I created, and the web page function I pass a target, the string to match on, whether I have verbose comments in it or not. So let's have a look at that webPage.py. You can see it enter here. This is using a library called MicroWebCli, and I'm very thankful that this was out here. So here's the actual library. It's under MIT license. It's been created by Jean-Christophe Bos, and if we go out to the GitHub repository for that, has a lot of really good documentation. There's 2 main ways of using this library. One is the fast methods, where it allocates buffers and does everything by itself, or these other more specific methods like get, where you have more control of the buffer being used. So I actually used the second method, the get one, because I didn't want to allocate huge buffers if a huge web page comes in. Can't say how thankful I am. I found this library, both that it's really well documented, works really well. So a lot of thanks to Jean-Christophe for doing this. The code in this web page, so really just follows that get example mostly. So it opens the request based on the target. I allocate a byte array of 1K. I don't want to use more than that for a chunk of memory. And then what it does, it goes into a loop here. So first, if it gets a successful response, and the response isn't closed, then it reads whatever buffer length of content into the buffer. Then it checks that in the buffer for the existence of the match string. Also returns a true if no match string or blank match string was passed. So if you don't want to match on content in the web page, you can just set the match to space, and it won't do a match, but it'll still give you a successful result in that case. This is a little different from the example. So whereas an example it does this in a while loop, so it pulls in all the content of the web page. I only just pull in the first 1,000 bytes. So you just need to make sure if you're going to use a match string that you match on something that's in the first 1,000 bytes. I don't really see the need to pull in the whole web page. Some web pages are really big. And also while that's going on, it's getting elapsed time, and I'm using that as time to first byte. It's not strictly true that it's time to first byte, but it's pretty close, as far as close enough to be usable for what I want to do with the probes.